Welcome to Linear Story College class, and the topic that we have here is homogeneous linear equation with constant coefficients, and it is of this particular form, that's P naught d raised power n y dx raised power n up to Pn of y. So we have Pn, then we have y equals to Q of x. So, and we have the characteristic equation. This is the characteristic equation, the second equation that we have here, and all these m1, m2 up to mn, they are referred to as the characteristic root, and we have a differential equation here, and they ask us to solve it. So we have to solve this particular question. So the first thing is to take this to the d operator form, and taking this to d operator form, that will be d cube minus d square minus 12d in bracket. Here we have y equals to 0. So we have it in d operator form, and since the power of this one is of order 3, so the highest degree here is 3. That means we're going to have 3. We're going to have 3 roots. We're going to have 3 characteristic roots. So from here, we'll take it to characteristic equation. So that will be m cube minus m square minus 12m equals to 0. So here we have the characteristic equation. So this is the characteristic equation. And if we observe this very well, we can see that m is common to everything. So that means you can factor m out into, that will be m square minus m minus 12 equals to 0. So since m is common to everything, we can have it like this. So don't forget that we're going to have 3 roots. We're going to have 3 roots in this case. That will be m1, m2, then and m3. So here we can see m1 is equals to 0, or m squared minus m minus 12 equals to 0. So here, since we have 2 brackets, m in bracket of this, so that means m is equals to 0, and everything I say is also equals to 0. So we can say m1 is equals to 0, or m squared minus m minus 12 is equals to 0. So now we need to obtain the values of m2 and m3. We already know the value of m1 in this case. And to obtain the value of m2 and m3, this is a quadratic equation. So we need to factorize this. We can factorize, or we can use the quadratic formula. So to factorizing this, we're going to have the sum there, that's minus m, and the product, so that is this times this, that will be minus 12m squared. So we look for two numbers, so that when we multiply the two numbers, we are going to have minus 12m squared, and when we add these two numbers together, that will give us minus m. That is, we multiply the two numbers, it will give us minus 12. Then by the time we sum it up, it will give us minus 1, the coefficient of this m that we have here. And the two numbers, the two factors, that's 4m minus 4m, then here we have plus 3m. So minus 4m plus 3m. So by the time we sum these two factors together, it will give us minus m. And by the time we find the product, it will give us minus 12m squared. So that means from here, we'll go back to this particular equation that we have here. Instead of writing negative m at the middle, we can actually replace it with these two factors that we have here. Those two factors. So that means we're going to have m1 equals to 0, or m squared minus 4m plus 3m minus 12 equals to 0. So that's what we're going to have from there. And that means m1 is equals to 0. So here we have m1 is equals to 0, or from what we have here, m is common to these two. That will be m into m minus 4. Then between this and this, 3 is common. That's plus 3 into m minus 4 equals to 0. So what we have inside the two brackets must be the same thing. So now here, if we multiply these two brackets that we have here, we are going to have minus, and that will be m squared minus 4m. And by the time we find the product of this, that will give us plus 3m minus 12. And we are going to pick this, that will be m plus 3 in brackets. Then we are going to pick one out of the two brackets, which is m minus 4, since they are the same, equals to 0. So we can actually go back here. So from what we have there, m1 is equals to 0, or here we're going to have m plus 3 equals to 0, or m minus 4 equals to 0. So in this case, we have m plus 3 times m minus 4. Everything is equals to 0. That means m plus 3 is equals to 0, and also m minus 4 is equals to 0. So from here, I need to have the value of m1 is equals to 0, or m2 equals to minus 3, or m3 equals to 4. So here we have m1 is equals to 0. Here from here I need to obtain the value of m2 from here, and from the other side, the last one, I need to obtain the value of m4. So here we have distinct roots. And in the case of distinct roots, under homogeneous linear equation with constant coefficients, so the primitive will be of this particular form. So the primitive will be of the form that will be y equals to c1 exponential m1x plus c2 exponential m2x plus c3 exponential m3x. So it depends on the number of roots that we have here. It depends on the number of roots. Here we have m1, m2, m3. So I need to stop over there. So then we have the case of repeated roots. The primitive will be very much is actually different from this. Then we have partly repeated roots. The primitive of that one is also different from this. Then we have the one of complex roots. The primitive of the one of complex root is also different from this particular one. So in our next videos, we'll be solving something of such on repeated roots, partly repeated root, and complex roots. So from here, all these C1, C2, and C3, they are the essential arbitrary constant that we have there. C1, C2, C3. Since you have three roots, we need to have C1, C2, C3, then M1, M2, M3. So I need to substitute the value of that's M1, which is 0, then times x, plus here we have C2 exponential M2, which is negative 3x, plus C3 exponential, this one is 4, then we're putting x at the back. So this one, that will be y equals to C1 exponential 0 plus C2 exponential minus 3x plus C3 exponential 4x. So from here, this implies that we have C1, anything is past 0 is 1, so that one is gone. C2 exponential minus 3x plus C3 exponential 4x. So that is the primitive of that differential equation. Kindly like this video, comment, and follow for more. Thank you.